So on this one, I want to start by finding the x-coordinates of the critical points of f. So what I want to do is I want to set f prime of x equal to 0 and solve for x. So that's my goal here. And so I'll notice on this function there are no places where the derivative doesn't exist. It's just a polynomial. So really the only critical points will be when the derivative is 0 here. So let's go ahead and find f prime. F prime is 3x squared minus 18x minus 48. And if I set that equal to 0, I can start by dividing everything by 3. Okay, and then let's see, factors of 16 are 8 and 2. Is this going to work? I think I can get a 6 out of that. So if I do x minus 8x plus 2, then that will give me what I need. So x is equal to 8 and negative 2. So those are the x-coordinates of the critical points of f. Then next it says determine the absolute maximum and absolute minimum value of f on the interval -5 to 15. So there's a theorem about this, and that theorem says that the absolute max and min can happen only at endpoints or critical points. So all we need to do is evaluate f at the endpoints and critical points, and then I can determine which is the absolute max and min. So f of -5, I want to compute f of -2, I want to compute f of 8, and I want to compute f of 15. So I'm just going to use my calculator to compute all of those values. One thing that students often try to do here is they try to plug into the derivative, but really we want the values of f. So we want to go back up here and plug into this function f of x. So when I plug in -5, I get -92. When I plug in -2, I get 70. And when I plug in 8, I get -430. And when I plug in 15, I get 648. And so the very smallest of these is this one. This is my absolute minimum. And the very largest of these is that one. That's my absolute maximum. And I was just reading here, it says work must be shown to receive full credit. So you might just show that you plugged -5 into the function. So I guess I didn't really show work there. -5 cubed minus 9 times -5 squared minus 48 times -5 plus 18 equals, and then you can write -92. So that's kind of a way you might show your work on that, even if you used a calculator. So on this one it says, a stone thrown into a pond produces a circular ripple. If the radius of the ripple increases at a rate of 1.5 feet per second, so that 1.5 feet per second, that's a value of dr dt, where r is the radius of the circle. How fast is the area growing when the radius is 8 feet? So let's let r be the radius of the ripple in feet. And let's let a be the area of the ripple, or area contained in the ripple, I guess. And this is in square feet. And so we're given dr dt, and we want to find dA dt. And so what we need is a relationship between these two rates. So what we'll start with is a relationship between r and a, and then I can take the derivative with respect to t, and those rates will show up. Well, if it's a circular ripple, I know that the area of the ripple is equal to pi times the radius squared. So that's just the area of a circle formula, really. And so if I take the derivative of both sides with respect to t, I'll get dA dt is equal to pi times 2r times dr dt. And that's just, I use chain rule there to take that derivative. Okay, because I'm really taking the derivative implicitly with respect to t, so that r squared is like a chain rule. Okay, so now I have a relationship between dA dt and dr dt, and so I can plug in the numbers at this point. So the dA dt is what I'm looking for. So pi times, and I want to compute the rate of change of the area when the radius is 8 feet. So I'm going to plug in 8 for r. And then dr dt is 1.5 feet per second. And so I'm just going to multiply all those things together. So when I multiply those together in my calculator, I got 75.398. Oh, it says state your answer as an exact value. Okay, never mind. Okay, so sorry, I just noticed it said state as an exact value, so in terms of pi. So if I do 2 times 8 times 1.5, that's 24. So I'll write this as 24 pi. And the units of that are the units of dA dt. The units of area are square feet, and the units of time are minutes. So the units of dA dt are square feet per minute. All right, so the last one says I have a function that's continuous and differentiable on the interval from 3 to 8. So I'm just going to draw this out because I think it might help us later. 3 to 8. And I have that f of 3 is 2. So that is a point on my function f. Also, I know that the derivative is less than or equal to 2. So that tells me that the slope of my function is less than or equal to 2. Then it says, what is the largest possible value for f of 8? So, well, if the slope of the function is less than or equal to 2, the largest possible value will happen when f prime is equal to 2 on the whole interval. So that would be, this positive slope of 2 here. If I have a function with slope 2, then over the course of 5 units, so from 3 to 8 is 5 units, then how far up would it go? Well, if the slope is 2, then if I go over 5, I'm going to go up 10 units. So the largest possible value is going to be 2 plus 10. So I'm already at the y value 2, but I'm adding 10 more. So f of 8 is less than or equal to 12 then, because the largest possible value for f of 8 will occur when f prime of x is equal to 2 on the interval from 3 to 8. And so if f prime of x is actually equal to 2, then that would be a linear function. And so the slope would be 2. So if I go over 5, that means I go up 10.